Hello, this is Aaron from ToolChef. In this video, I'm going to show you how to create a Navmesh and use the Navmesh to drive the agent to a target position. So I create a simple scene with a single agent with some geometry, two cubes that are used as wall, ground, and then some other geometry with a null that will be my target location. So let's start to set up the ground first for the eye field. So let's try this one. So I'm going to use this mesh as a eye field. Let's add a name there. Okay. Now let's add the new eye field to the state machine. Perfect. Okay, that's fine. Now let's try the ground. I have all the other geometry for the Navmesh here. So let's create the Navmesh. Go to the Navmesh manager. Add a new Navmesh. Let's add a name there. Select the geo. Let's wait that it's finished to compute the Navmesh. Okay. So let's close this. Let's have a look to the Navmesh. So the Navmesh is gonna create this Navmesh top node, and if I go to the guide and show guide, I see my Navmesh geometry. So let's have a look to the parameter of the Navmesh. Let me display in the top, and let's go here. So on the TC Atoms Navmesh nodes, you have all the parameters for the Navmesh. So the first one is to use tiles, so you can use basically tiles like these to compute the mesh. Every tile is computed on a separate thread, so it could be faster if your mesh is complex, large. In this case, we can probably go down a bit for the tile size. Let's put 300. Let's wait a bit. Let's finish. Okay. So as you can see now, the faces are small. So also this means that the nav path computed by the Navmesh will have more resolution, because the nav path basically is composed by all the points on each triangle that are basically on the path to reach the specific target. The other parameter here, so the cell size is basically the cell size, and cell height is basically the cell used during the voxelization of your mesh, because the Navmesh to compute these triangles voxelize all this volume. And so this parameter here control the size of its cell. Obviously, if you increase this one, it also decrease the quality and the precision of the Navmesh. The agent height itself basically it's a reference for the height of the agent. In this way, he know where he can compute the mesh. So for example, if you have some floating geometry and the geometry has a height higher than 70, then the agent can pass above this geometry. But if it's less, then the Navmesh will exclude that area. Let's increase the agent radius. So this one is used by the Navmesh to know where the agent can pass through. So these two is quite small. Let's add to probably 30. Let's wait. You see that now there will some change here. Yeah, because obviously this one is the radius, so this distance. So it guarantees that there is this distance between the walls here. Then the other parameter is the agent must climb. So this one is the maximum height that the Navmesh can generate. Basically, can generate a connection between a triangle that are on different height. For example, here I don't have a Navmesh here that connect these two area, because this one is higher than this value. If I change this one to I don't know, maybe 80, let's wait, let's finish the compute. sorry, no, it should be more 200. Yeah, as you can see now it's all connected, so the agent can basically go here and go on this geometry and continue. That's obviously is wrong in this case, so let's decrease. Let's put 20. Okay, the next parameter is the max slope. So here you can see how this value can affect the Navmesh. So now probably this one is like 50 or 20 degrees, this ramp, and my agent can walk on a terrain with a max slope of 45 degrees in this case. But if I lower, for example, to 10 degrees, then yeah, now the mesh is disconnected, so the agent can't reach anymore this point here. So let's go back to the max slope. Okay, and the other parameter are basically a parameter to control the triangularization of the mesh here, like the maximum edge of a triangle, maximum area, and so on. So play a bit with this value if you want to refine the triangularization of your mesh. So now our mesh is fine. We can use with a navigation module. Let's go to the agent group. Let's hide this guy because I don't need it anymore. Let's turn off this one and just go on the agent group. Let's add the navigation module. Go on the parameter of the navigation and let's select our mesh. Can turn on debug, see the navigation path. As you can see now, he is trying to reach in the target position, that is 0, 0, 0. So we can use this locator as target. So let's go here. Let's copy this channel, copy parameter, and go here and just pass relative reference, and now it's there. So as you can see now, the agent will follow this path if I go there. Let's have a look at the other parameter here. So we can compute the path at every frame, or if you turn off, it just compute one time and then the agent just follow that path already computed. The bug turn on the draw of the path, align in a frame, basically outline the agents along the path already at the beginning, and then the target metadata. So instead to use a target position here, explicit position, you can use a vector 3 metadata that contain the position of your target. And then we can have the target radius. Then basically, let's increase this one to 200. And this one tell basically to the module that the agent reached the target position. When you reach the target position, we can change some metadata value. So for example, we can change the state to 0. Now in this way, the agent will go in a idle state, and then the wait for the module. The only thing that we need to change before play the simulation is to turn on this option state machine, because in this way the state machine just set the state to 1 at the beginning, and then all the state is controlled by the other module. So let me turn on this one. In this way the target trigger can set the proper value there. So we have all set up. Let's play. Let's see if it works. Let's increase the here. That's it. Perfect. Thank you for watching, and see you in the next video.